Welcome back. This is the lesson where everything comes together. We've learned how networks work, layer by layer. Now we learn the command line tools that let you diagnose almost any connectivity problem, and crucially, a repeatable method to use them in. When a user says the internet is broken, you'll have a plan instead of a panic. Here's the mindset shift. When a user says the internet is broken, a junior tech guesses, but a good tech tests. A handful of command line tools, used in a logical order, will diagnose almost every connectivity ticket you'll ever meet. This lesson brings the whole module together into one repeatable method that you can apply every single time. First, ping. Ping sends a small message and times the reply. It answers two questions: can I reach this host, and how fast is the round trip? Replies mean reachable. Request timed out, or destination host unreachable, means a problem. The trick is to ping targets in order: 127.0.0.1, your own stack, then your gateway, then a public IP like 8.8.8.8, and finally a name. Next, ipconfig. It shows your address, mask, and gateway, and confirms whether DHCP worked. Use /all to also see your DNS servers and MAC address. And use /release, /renew, and /flush DNS to fix DHCP and DNS issues. Remember, a 169.254 address here tells you DHCP failed, so you don't waste time looking elsewhere. Now tracert, or traceroute. It maps every router hop between you and a destination, with timing for each one. This shows you where along the path traffic slows or stops. If the very first hop fails, the problem is local, on your machine or router. But if it dies several hops out, the fault is upstream at your provider. That's not something you can fix, but knowing it is vital, so you escalate instead of wasting hours. We've met this one already: nslookup queries DNS directly. If pinging 8.8.8.8 works but website names fail, nslookup confirms the DNS fault and shows you which server answered. This is the tool that separates a name resolution problem from a true connectivity problem, and that distinction saves you enormous amounts of time. Here's the method to memorize. Work bottom up through the layers and stop at the first failure. 1. Check the physical link light and cable. 2. ipconfig for a valid address. 3. Ping your gateway. 4. Ping 8.8.8.8 for the internet by IP. 5. nslookup a name to test DNS. Each step that passes rules out a layer, and the first one that fails is your fault. This checklist alone solves most tickets. Let's work a real ticket. A user says their email won't load and the internet is down. You run ipconfig, the address is valid, good. You ping the gateway, it replies. You ping 8.8.8, it replies, so the link to the internet is fine. Then you run nslookup and it fails. There's your answer: it's a DNS problem. You flush the DNS cache, retry, and email loads. Method, not guesswork, found it in under a minute. Let's recap. Ping tests whether a host is reachable. ipconfig shows your configuration. Tracert finds where along a path traffic breaks. And nslookup isolates DNS faults. Most importantly, you now have a bottom-up method. Your task: run the full sequence on your PC, ping 127.0.0.1, your gateway, 8.8.8.8, then nslookup. Record each result, run tracert and count the hops to Google, and write a one-line conclusion. Next time, network security.